So Helena Hanshush is up next. You can throw the cube. 3 for 3. Okay, thanks.
On?
Yeah, you have the clicker?
Yep. Okay. Hello? Yep. Okay, thank you. Clicker. All right, so title of this very short talk, actually. An open source approach to system security. My name is Helena Hanshu. I have the pleasure of chairing the Security Standing Committee of the RISC-V Foundation. I guess the foundation has realized last year at the event of Spectre and Meltdown and other newer style of side channel attacks like that, that security is an active component of systems today, and that maybe we should start looking at it. So here we go. Okay, so why do we need an open source approach? Well, there's several different reasons for doing that, but really what this is about is that it's easier to do it together. If you share specifications with peers, you can actually look at them with many more eyes. You can discuss them, you can debate and make it better and more secure. You go faster. Testing is going to be way more effective, specifically in the security domain, because there's always a notion of an attacker role and a protector goal. So if somebody tries to develop it, it's difficult for them to, at the same time, try to attack the system because they just designed it. So if you have somebody else looking at it, it'll be easier for them to try to attack it and then come up with solutions together that altogether are more secure. Compliance is critical to build up an ecosystem, so we need to do this open source-wise. We need to do this together because once things are compliant, it is easier for everybody to work on top and build on top. We need interoperability, so if people decide to develop things in their separate corners, what is the chance that this will be interoperable in the end? It's not very big. So to build an ecosystem, we need interoperability. We need to make sure we share specifications, we share how things work, and then everybody can build on each other's results. We don't want to do security by obscurity. That has never worked. Open sourcing everything and trying to explain how things work will make security features and functionalities way better. Open formal models allowed to test for security issues. So now we're talking compliance, but in the security domain. You need to formalize, you need to model everything and try to reason about security by building tools for that. So that's the next step, building formalization of security testing tools, trying to develop models to reason about it. How does an attacker think? How does a protector think? Formalize both of these, run tools, test tools on your specification. Also then make tools available to the entire community so that everybody can use it for their own systems. And reason about these models and the functionality. All right, I hope I justified it enough. Now, what about embedded system security approaches? Well, here are a few ways that the RISC-V Foundation and the security committees that it does entail can help designers of secure cores, secure systems, and SOCs. So let's start from the start. We do have a first clean slate with RISC-V open specifications. These are public, they're on the web, everybody can see them, use them, completely free, completely open source. Let's start with that and build on top. So now what do you need for secure processors? Well, a few different ingredients. We need, first of all, the base instruction set, but then we already have a privilege spec that's defining privilege modes, 4 of them. I believe the first one is ratified, the second one right on its heels. And then on top of that, what else do we need? Well, we need a couple of things. These things in the security domain are called security extensions. And right now, 2 of them are being worked on very actively. One of them is called crypto extensions. This one is driven by Richard Newell from Microchip. And the second one is called the Trusted Execution Environment Task Group, and this one is driven by Joe Shi from NVIDIA. So one of them allows to accelerate crypto operations. The other one tries to reason about reason around what do we need as hardware extensions for building up a trusted execution environment. And then once you have these, then you can start trying to define what secure processing means and what you need for that. So one example is a secure boot process. We've just had a very nice presentation about what secure boot is all about and how that works. You need cryptographic algorithms and keys, and you need the extensions to be able to call them. You need the actual environment in which your applications will be allowed to run. On top of that, your secure applications and some form of interfaces to the user, but also at the supervisor mode, as we've seen in the previous presentation, 2 or 3 presentations ago. So these are all building blocks and elements to build up secure processing. So in terms of RISC-V Foundation task groups relating to security, beyond the Security Standing Committee, which is sort of a permanent committee, we have task groups that build up to form actual specifications and actual extensions. So the 2 I mentioned already on the previous slide, crypto extensions and the TEE group. On the crypto extensions part, the group is working on an approach which is itself based on vector extensions. And the 2 first items that the group is working on is some specific instructions for running AES. There's a 1-round approach and a full round approach, and specific instructions for running SHA-2 hash algorithms. A 1-round and a full round approach as well in this case. The other part here in this group is to try to model how public key crypto algorithms could run on previously existing extensions. So how do you implement long integer arithmetic on this? How do you make a proof of concept implementation on RISC-V specific instructions? There is a presentation from the crypto extensions group later today, I believe around 4 or 5 o'clock. So you will see more about that. The TEE task group on its side is looking at secure boot specifications. What does that mean on a RISC-V processor? How does this look like? Try to specify exactly what needs to happen. And independently also is looking at 2 other activities. One is to define PMPs, the physical memory protection. There's a proposal on the table right now that's being debated and voted on, and as soon as this goes public, it will be on the RISC-V website. Also an IO PMP proposal and a few other initiatives going on. So in our time scale, when we say it's almost done, it might take a few more months to get done, but once it is done, then it becomes public and everybody can see it. Sorry. Okay, so security measures can do benefit from an open approach. We've seen recently that the newer cache timing side channel attacks are mostly resulting from, I'd say, microarchitectural flaws and implementation flaws. These are things that cannot be specified at the ISA spec level because this is 1 layer below. So we can't directly eliminate and fix it here, but what we can do is try to bring up some generic solutions that could help. And in this case, recent discussions have concluded that we should try to include this at the platform spec level. Platforms are all specific and different, so your solutions at the hardware level will be different, but you can specify things at that level that would allow you to call hooks or to build in hooks or to call specific instructions that will help mitigate these things. So, for example, what's been discussed is why don't we add something like a flush instruction? Why don't we add instructions or hooks that make it such that memory accesses and shared cache pieces are all separable? That means that different processes that try to access common resources should actually not be allowed to do so. How do you make sure to separate the rights that pertain to specific areas such that the cache overlaps and the fact that processes call different from different sides to the same cache areas, and that's the part that leaks information, right? So that this isn't possible anymore. So we can try to add specific platform-specific flush instructions. We can try to add access permissions on sorts of cache and memory spaces. And this is what we're trying to look at in in terms of building it into platform specs. So the standing committee, after some discussions, has been talking about Galwa, the Galwa firm taking the lead here with a firm platform spec coming out at DEF CON next month. It will describe a secure voting machine. This actually doesn't exist today, so we all hope that this will be an interesting initiative. It will be open for people to look at and to hack into. And Gernot Heiser from Data61 was very keen on following up with a platform spec based on SAL4. A few other topics that the committee is looking at in the form of its vice chair from Galwa. The company participates in DARPA SITH projects, and these are all security related. So what they're looking at, and hopefully will be able to contribute to the foundation soon, and soon means, you know, a few months from now maybe. They're working on something called Lando. That's a formal specification for hardware design, which has 4 sub-languages. These sub-languages address, there's a system spec language, there's an architectural language, a product line engineering language, and a security property specification language. So the idea here is to be able to formally describe security properties, propose guarantees, and to formally verify your implementations against it. There is also a domain model for specifying these security properties. For example, they've tried to start formalizing the NIST CWEs relating to buffer and memory errors in that specific domain modeling. This was also something that will all be made publicly available and contributed to the RISC-V Foundation as soon as DARPA gives its green light for it. And finally, there is a tool suite called BESPIN. Don't ask me for the acronyms, look them up on the internet. There's too many letters here. But the part that was already contributed to the RISC-V Foundation is called GRIFT. And it's a subsystem of that tool suite that is contributed to the formal specs group so that you can formally verify things. And finally, I already mentioned that the secure voting machine platform spec includes security properties and guarantees and will be shown in an open framework at DEF CON next month. And there is 6 more platform specs that the group is working on, the Galwa company, I should say. This is not the foundation, this is Galwa. But these are based on RISC-V SOCs, and the 6 ones that they picked are Rocket and Boom from Berkeley, Piccolo, Flute, and Bassoon from BlueSpec, and RISC-V from MIT. So a lot of stuff happening, platform specs along to formalize security properties, guarantee things. This is a little bit of a first, and we hope it goes a long way. And finally, in my last 10 seconds, there is still a lot to be done. Security is a very, very broad field. It's not simple, and there's very few tools available that formally do things. So still a lot of work to be done. Please join us, join the foundation, join the security committees, and help us get it done. Thank you.
Okay,